In this video, we will be looking at the line of best fit. By the end of the lesson, you should be able to determine the equation of the line of best fit in order to make predictions and solve real-world problems using mathematical models. So let's take a look at some examples. In this situation, Mrs. Marsh took data from her classes and found that for students who studied more, their test scores were higher. The following is a graph of the data. If this trend were to continue, what would a test score for a student who studied 10 hours be? Okay, so here I have my data. If we look at this graph, it's different than the graphs that we've seen so far in this unit because my points are not exactly on a line. This is what we call a scatter plot. And we'll talk about that some more in just a minute. But because our points are not exact, we need to estimate. And if we look at this graph, I see 0. In between here, there's a 1, 2, 3, 4, 5, and so on. Same thing up here. I have 50, so in between is 60, 70, 80, 90. Up here is 100. Okay, so my question asks, what would a test score be for a student who studied 10 hours? Well, my graph only goes up to 8 hours. But if I know 5 is here, 6, 7, 8, 9, here is my 10 hours. And my graph, I'm going to use this graph to predict. So if it kept going and it made it to 10, so if I estimate, if I draw a line through here, if I estimate just about here, what would a student score if they studied 10 hours? Well, if I look at my graph, they would score about 100. Their test score would be equal to 100. This is an estimation. We are using this graph, these data points that she collected to predict what might happen. So let's take a look at some other examples and talk about some vocabulary first. So what we just looked at was a scatter plot. This is a graph that's used to determine whether there is a relationship between paired data. Scatter plots can show trends in the data. And we have 3 types of scatter plots. If we notice here, this first one, it says positive correlation. That correlation is the same thing as the relationship. That's the relationship. So if I look here, this one, positive, it looks like it has positive slope or increasing, so it is positive correlation. Negative correlation looks like it has negative slope. It has a negative relationship. No correlation, if you notice here, our points have no relationship. They're not increasing or decreasing. The data points have nothing in common. Our line of best fit is a line just like we drew in our first situation. I drew this line as an estimation. Our line of best fit is a line used to model the trend having a positive or negative correlation. So my line of best fit is what I can put to estimate what is happening in the data set. So let's go back to Mrs. Marsh's class and try and answer another question. So what is the most likely equation of the line of best fit for the set of data points? So if we were to draw that same line, through my data points, what would the equation of that line be? Well, remember, for an equation, I want to write it in y equals mx plus b. Earlier in the unit, we looked at graphs to determine these. Remember, I need my 2 parts. I need my m and my b. Let's see if I can get those from the graph. Well, my y-intercept, or my b, I can see is right here. My graph touches, here's my y-axis. My graph touches my y-axis at 50. That one's a little bit easier to see. My next one is my m, or my slope. And remember, I want to pick any 2 points on the line and find my slope. Here's 1 point. Here's another point. For my slope, I go up 1 over 2. So my slope is 1/2, and I know that it's increasing. It has positive slope, positive correlation, so it is positive. So when I write my equation, I'm going to write y equals 1/2 x plus 50. This right here is my line of best fit. If you flip your paper over, let's take a look at some other examples when it's not a graph and it's just a table. So in example 2, the table, that's my table, shows students' test scores and how many hours per day they spend on their phone doing activities that are non-school related. Okay, so when I look at this table, I see I have the number of hours per day on their phone. So somebody who spends no hours on the phone may get a 98 on their test score. Someone who spends 2 hours might get an 88, 4 hours, 75, and so on. So this question, question A, is asking us the same thing. What is an equation that represents the line of best fit for the data? So in this case, I don't have a graph, so you're going to need to use your calculator. And I have my instructions. We're going to reference here how we're going to use our calculator. So if you take your calculator out, we are going to first hit stat. We need to enter in the data. So we're going to go to stat and then edit, which is just enter. And I have some data in mind, so I'm going to clear it out. If you have data in yours, you might need to hit clear. You go up, hit clear, and hit down. So once I'm clear, I'm going to enter in this data. You want to put your top values in L1 and your bottom values in L2. So my number of hours per day on the phone are going to go on my L1. So I have 0, 2 hours, 4 hours, 6 hours, 8 hours, and 10 hours. And then in L2, I'm going to put my data that's on the bottom, the test score. So I'm going to put 98, 88, 75, 65, 57, and 40. I always want to check. I'm going to double check my numbers because it's easy to make a mistake here, and I want to make sure that I have the right numbers. 98, 88, 75, 65, 57, and 40. 0, 2, 4, 6, 8, 10. Once I know my numbers are correct, I'm going to finish with my steps. To get the best fit line, I want to hit stat again and then go over to calc. So I'm going to hit stat again. Now instead of going to edit where I just was, I'm going to arrow over to calc. And I want number 4. Notice how it says AX plus B. I want to go to number 4. Then I'm going to hit enter until I get to calculate, and I'm going to ask my calculator to calculate this. Now notice that this gives me my equation in the form y equals ax plus b. A is the same as m, and it gives me the values for both of those. So instead of writing the letter A, I'm going to round my A value, and instead of writing B, I'm going to round my B value. So when I write this down, I'm going to write, so A is equal to negative 5.6, and B is equal to 98.6. So I'm going to write it as y equals negative 5.6 x plus 98.6. That is my equation. That is my line of best fit. When I go back, if I notice here, I have some different variables. I don't have x and y, I have h and t. So I'm going to go ahead and substitute just so I have the correct variables. So my test scores are going to be equal to negative 5.6 times my hours plus 98.6. That is going to be my equation for the line of best fit. If we look at letter B, we see if this trend continued, what would be the test score for a student who spends 14 hours per day on their phone? So what would be the test score? So remember, test scores were T, and 14 hours is H. So what would be the test score? I want to know what a test score would be if somebody was on their phone for 14 hours. So now I'm going to substitute and say test score is equal to negative 5.6 times the hours, which we have is 14 hours, plus 98.6. Now I just need to solve this. I can use my calculator again. When I'm in here, I can hit clear. I can hit clear. And I want to type this equation in. Negative 5.6, negative 5.6 times 14 plus 98.6, and I get 20.2. So a student who was on their phone for 14 hours might get a 20.2 on their test. This is the end of our video. We will continue practicing and using these calculator functions together in class.